Okay, so I'm Nilmoni and I'm from IIT Kharagpur and so I'm the TA of this course, Transform Calculus and its application in Differential Equation, and this is the PMRF NPTEL Weekly Live Session 6. Okay, so today we will see some problem about your Fourier transform. Okay, we will learn how to calculate a Fourier transform. And sometime we will use Laplace transform. Already we have done in last few week. Okay. Yeah. Okay. So this is the first problem. It's a very easy problem. Okay. Uh, so yeah. Yeah. So first problem is so if this function fx is defined 2 minus x square when x lies between minus root 2 to root 2, and it takes 0 when like otherwise. Okay. Okay, so I hope you already know the formula of Fourier transform. Okay, so fx is given by 2 minus x square when minus root 2 less equals to x less equals to root 2 and 0 basically mod x greater than root 2. Okay, so Fourier transform, Fourier transform. Instead of this, I can write like this also. Okay, if x, 1 by root 2 pi, integration minus infinity to infinity, fx time e to the power I alpha x. Okay, this is already from lectures. Okay, and now see, fx takes 0 when mod x greater than root 2. So root 2 to infinity and minus infinity to minus root 2. So f is 0. So basically, so we have minus root 2 to root 2, 2 minus x square e to the power I alpha x dx. Okay. So now what you will do? Okay. So you will use by parts. Okay. To integrate this. So 2 minus x square is first function and e to the power I alpha x second function. Okay. 2 minus x square e to the power I alpha x by I alpha, so this and minus root 2 to root 2, and then you see what is the derivative of 2 minus x square. This is minus 2x. Okay, this is minus 2x, so minus and minus plus 2 and divided by I alpha integration minus root 2 to root 2 x e to the power, oh my god, sorry, I don't know. This is okay. There is some problem. Okay. Yeah. Hello. Am I audible, right? Okay. So e to the power I alpha x dx. Okay. and then if you put the upper limit and lower limit, so one thing you can see here, okay.
Directly Bernoulli's theorem.
Bernoulli's theorem means, can you explain it?
UV minus U dash V1 and so on. I don't use this formula.
UV. So I don't understand what you are saying.
First one is right. 2 minus x square e power I alpha x divided by I alpha. Then minus, you differentiate the first terms.
Yeah,
0.
I am doing this, right?
No, I think this is a one continuous, continuous thing. That's why I'm
Okay.
it's okay. Right?
Okay. Mm-hmm. Yeah,
This is
so
much more time to that's why I'm
okay. Okay, that is also good. Now, if you put here root 2 and minus root 2 for this term, so it will be vanished, right? So root 2 is 2 and minus root 2 square is 2. Okay. So then, now, just 1 by root 2 pi into 2 by I alpha, and you see, you have to integrate this, right? You have to integrate this x time into the power I alpha x. So, x e to the power I alpha x divided by I alpha minus, the derivative of x is 1. So, you will have uh, e to the power I alpha x e to the power I alpha x divided by I square alpha square. Okay. So, you have to integrate 2 times. Okay. And minus root 2 to root 2. Now put the value. So, you can write like this 2 by pi and 1 by I alpha. And also, okay, so root 2 e to the power I alpha root 2 divided by I alpha minus. So, this is a plus actually. Okay, I square is minus 1. So, you can write plus e to the power I alpha root 2 divided by alpha square, and then minus and minus plus, so root 2 e to the power I alpha root 2 divided by I alpha, and then plus is already there, so this will be minus, not minus, you see,
minus is 6.
minus, minus, yes, minus, okay. So e to the power minus, e to the power minus root 2 I alpha divided by alpha square. Okay, now you can simplify it.
I think
Yeah.
third one
Is there any
also
problem?
minus is. Third one is
Hello?
also minus
Minus?
is missing.
In which term?
Third one.
No, you see. So I square is minus 1, right? So this is already plus.
No. Then e power I alpha minus root.
Uh, no, minus root 2 I alpha, right? So you are putting for lower limit, okay? You are putting this lower limit
Yes.
here. Yeah,
Putting in
so
lower
already this is plus. So instead of this, you can write
No,
uh
exponential power.
exponential power, yeah. So
Minus
minus
is missing.
no, e to the, oh, yeah. In third term, right? Okay, you should mention third.
Yes.
Yeah, you are right. You are right. minus root 2 I alpha. For third term, okay, not fourth term. Okay, thank you. Now you do one thing. Alpha. Now here, so e to the power I alpha here also. So sorry. Okay. Yeah. So so now just here e to the power basically just so yeah, in question, so in problem, so it is given like that. Okay, so sine root 2 alpha cos 2 alpha. Okay, so you have to make it like that. Okay, so yeah, so root 2 I alpha is common. Uh, root 2 I alpha is common. Then e to the power I alpha root 2 minus e to the power minus I alpha root 2 divided by 2, and here for adjustment you can take here root 2 and 2, and then okay, then plus 1 by, so 2 by alpha square e to the power okay yeah, I alpha root 2 minus e to the power minus I alpha root 2 divided by 2. I hope it is clear up to now, right?
I think the first term is not minus, plus.
Yeah. Right. Thank you. Yeah.
The second
So
one, you multiply qi is possible.
yeah, you have to do it actually. You have to do it. Otherwise, you don't have formula, right? Yeah. Thank you. Yeah. So yeah, and then 2 root 2 I alpha. This is cos alpha, right? Cos means cos x formula. So
Yes.
this is cos root 2 alpha. Yeah, and then 2i and alpha square sine root 2 alpha. Actually, so let me write it. Maybe cos x equals to e to the power ix plus e to the power minus ix by 2, and sin x equals to e to the power ix minus e to the power minus ix by 2i. These two formula we are using. Okay, this is very simple because you know cos x plus I sin x. Okay. Okay, so finally you are getting this. Okay. Um, Now one thing you can do, okay, for simplification, okay, you can come on what? You can come on 2 by root 2. Yeah, 2 by root 2, maybe 2 root 2 if you come on. Okay. No, you should the answer. Okay, 2 root 2 and 2 by root pi. Okay, you have to make it. Okay. Yeah. Oh, okay, here alpha square is there. So
P not
basic.
LCM I alpha
Uh,
square.
yeah. And you have to make it here alpha q also, right? And then so I is there. So you multiply I, okay, and then you will have and what root 2 and root 2 and root 2 and 2 is also there. Okay, outside, and alpha, because you are multiplying, sorry, you are multiplying alpha q in denominator and numerator. So and then cos root 2 alpha. Okay, and here also plus okay, yeah, here only sign because alpha q and alpha q. So alpha is there, right? So here alpha, so see, so alpha was already in outside, so that's why alpha and alpha cube. So okay, so basically this is sine root 12. Is it okay now?
Yes, correct.
Yeah. Okay, so let me write the final answer. So basically the Fourier transform fx is 2 root 2 what? 2 root 2 by root pi, 2 root 2 by root pi, 1 by alpha cube into uh, okay, sine root 2 alpha minus root 2 alpha cos root 12. Okay, so okay, let me check which option is correct. Yeah. So alpha cube is sine root 2 alpha and root 2 alpha instead of 2 alpha. Okay. And also in fourth option, so sine 2 alpha is there. So option C is correct. Okay. Yeah. So I hope it is clear. Okay. So only calculation you have to do. Okay. And yeah, next problem. Uh, so you have to find the Fourier transform of e to the power 2x times e to the power minus e to the power x. Yeah. So your fx is e to the power 2x e to the power minus e to the power x. Okay. So Fourier transform is 1 by root 2 pi minus infinity to infinity fx e to the power I alpha x dx. Okay. 1 by root 2 pi. Here you have to put the whole thing because it sorry, minus infinity less than x less than infinity. Okay, so e to the power 2x e to the power minus e to the power x into e to the power I alpha x dx. Okay, so now here what you will do? Okay, so e to the power minus e to the power x is there, so you just put e to the power x is there. Then dz is e to the power x, so dx, right? E to the power x. Also, e to the power x equals to what? E to the power x dx. E to the power x is equal to z. So e to the power 2x is z square. No problem. And also you have to check the limit. Okay. So x and z. When x equals to minus infinity, so this is z equals to 0, right? Infinity, infinity. So 1 by root 2 pi 0 to infinity. Okay, e to the power 2x means z square. E to the power minus z. Also, dz is what? dz by z equals to dx. So dx is dz by z. Okay, and here what you will do? E to the power x equals to z. So z to the power I alpha and dz by z. Okay. Now,
Lim- Limit is infinity to 0.
yeah, no, minus infinity to infinity. So this is 0 to infinity, right? So when x is minus infinity, then z is 0. Am I
Yes,
correct?
sir. Yes, sir. Yes.
Yeah, yeah. So then, if you collect the power of z here, z square and z, so z to the power 1 and here z to the power I alpha. So you can write here like this 1 by root 2 pi 0 to infinity. So you know gamma function, right? So I alpha plus 2 minus 1. Okay, and e to the power minus z digit. So gamma what? Gamma s equals to what? 0 to infinity e to the power minus z e to the power minus z or what? No, yeah, e to the power minus z and z to the power s minus 1 dz. Yes, this is the definition of gamma function.
Yes.
And yeah, so here 1 by root 2 pi. So see, so this is the like exponent, this I alpha plus 2 and e to the power minus z. So this should be gamma I alpha plus 2. Okay. Yeah. So you don't know the value of alpha, so that's why you can simplify it. Okay. I don't know. I know what is the option. Yeah. Gamma I alpha plus 2. Option C is correct. You can simplify it because you know gamma s plus 1 is gamma s. Okay. Yeah. I don't know. It is it works for complex number or not. I don't know. Okay. So maybe it works. Okay. When S is complex, maybe it works. I don't know exactly. Okay. Okay. So for so here option C is correct. Okay. You don't need to think further. Okay. So yeah. So here you know direct delta function. Okay. And direct delta function is like uh, takes 0 when x equals to sorry 1 when x equals to infinity and 0 otherwise, right? Basically otherwise. So one formula you should know, infinity to infinity fx delta x dx is f of 0. So I think if you learn measure theory, Lebesgue measure, okay, from there it comes actually. Okay. So in only when x equals to infinity. Oh, yeah. I am wrong actually. I am wrong. When x equals to 0, this is 1. Otherwise, yeah. Okay. Now it is clear. So, yeah. So at the point 0, it takes 1. So that's why so at the 0 point, so you will have some like some something like means if you integrate this, then you will have some quantity. Okay. Otherwise, it is like 0 everywhere. Okay. I hope you have seen this. Okay, this formula, and you know what is direct delta function. Okay. So this formula we will use. Okay. And so fx is what? Fx is delta x plus pi plus delta x plus 2 pi. Okay. Okay. Let me check what is the Fourier transform. 1 by root 2 pi minus infinity to infinity fx e to the power I alpha x dx. Okay. 1 by root 2 pi. So root 2 pi. Okay. Root 2 pi. Not root 2 times pi. Root 2 pi. And yeah, minus infinity to infinity. So delta x plus pi e to the power I alpha x dx plus 1 by root 2 pi minus infinity to infinity delta x plus 2 pi e to the power I alpha x dx. So 1 by root 2 pi. So you see here when x equals to minus pi delta, so then it will become delta 0. Okay, so basically you see here when delta is so x is 0, then only so it will be survived. Okay, so yeah, basically it will have e to the power, so instead of x, you have to put minus pi. Okay, e to the power minus I alpha pi. Okay, and plus e to the power minus alpha 2 pi. Okay, so you can write like this: alpha pi e to the power minus 12. Okay, got it? Hello, am I audible?
Yes, sir.
Yeah. Did you get it right?
Yes, sir.
Okay. So yeah, so option A is correct. Yes. This is the next problem. Next problem. So next problem is the function is simple. Okay. Yes, you have to integrate. Okay. So let me write here the function 1 plus x minus 1 less than x is equals to 0, 1, 0 less than x is equals to 1, 1 minus x, 1, 0 otherwise. So did you complete whole lecture up to now, up to like week 6? Hello? Yeah. Did you complete the whole lecture up to week 6?
No, sir.
Means in video lecture.
No, sir. Last two lecture is not complete.
Okay. Okay, no problem. But you know the formula, right? For Fourier transform formula. So only we are using the formula. Okay, main formula. Okay, definition. Yeah. Okay. So if you have problem, you are facing problem, any problem, so you can ask me. Okay. Fx and so this is the formula: minus infinity to infinity fx to the power I alpha x dx. Okay, so simply minus sorry. So otherwise, so basically the limit should be minus 1 to 2. So minus 1 to 0. So this is 1 plus x a to the power I alpha x dx plus 1 by root 2 pi integration 0 to 1 e to the power I alpha x dx and plus 0 1 to 2 1 minus x e to the power I alpha x dx. So here also you have to use by parts. So 1 plus x time e to the power I alpha x. Okay. So 1 by root 2 pi 1 plus x then e to the power integration of e to the power I alpha x e to the power I alpha x divided by I alpha, and this is minus 1 to 0, and here so the derivative of 1 plus x is 1, and you have to integrate 2 times e to the power I alpha x then, and you will have e to the power I alpha x divided by I square alpha square. So I square is minus 1, right? I square is minus 1. So alpha square, and instead of minus you can put plus. Okay, and this is minus 1 to 0. Okay, and plus so you have e to the power I alpha x. So e to the power I alpha x divided by I alpha. 1 by root 2 pi is also there, and this is 0 to 1. And similarly, for last term, last integration, 1 minus x e to the power I alpha x divided by I alpha by 1 to 2. And here you see the derivative of 1 minus x is minus 1. So that's why e to the power I alpha x divided by alpha square. Okay. And this is 1 to 2. Now put the values of lower limit and upper limit in each integral. And so when you put 0, we will have 1 by I alpha and plus 1 by alpha square minus, when put minus 1, so this is 0. And if we put here minus 1, so e to the minus e to the power minus I alpha by alpha square. Okay. And here if you put e to the power I alpha divided by I alpha. Okay. And minus 1 by I alpha. And then if you put here 2, so 2 minus e to the power 2I alpha by I alpha, and then 0, you will have 0 minus 0 and minus e to the power 2I alpha by alpha square and plus e to the power I alpha divided by alpha square. Okay, so one alpha will cancel, and I think, yeah, no, now you have to calculate. Okay, so okay, let me write it. 1 by root 2 pi. So you see, you can common alpha square and 1 by I alpha. Okay, so 1 by alpha square, and then you see 1 by alpha 1, then minus e to the power minus I alpha, and e to the power minus e to the power 2I alpha and e to the power I alpha. Okay, so 1 minus e to the power minus I alpha minus e to the power 2I alpha plus e to the power I alpha, right? Sorry. Sometimes it happens. Yeah, so e to the power I alpha and plus 1 by alpha time e to the power I alpha, e to the power I alpha. Why it is happening? Okay. I to the power I alpha minus e to the power 2I alpha. Okay. Well, actually, this is the final answer also. Okay, you don't need to simplify further. So e to the power I alpha minus e to the power 2I alpha divided by I alpha plus 1 minus e to the power 2I alpha plus e to the power I alpha minus e to the power minus I alpha divided by alpha square. Okay. What happened? Okay. So option is not okay. Sine alpha is there. Okay. So you have to make it sine alpha here. Okay. So e to the power I alpha minus e to the power minus I alpha. This is what? This is 2I sine alpha, right? E to the power I alpha minus e to the power 2I alpha divided by I alpha plus 1 minus e to the power 2I alpha plus 2I sine alpha. Okay, and alpha square. Now it is okay. Yeah. So the like A and B are different. Okay. So B is correct because e to the power I alpha minus e to the power 2 alpha divided by I alpha and 1 by alpha square times this. Okay. Okay. Is it clear?
Yes, sir.
If pause,
What?
no gamma integral formula.
Okay.
In
Sorry, I cannot understand your voice. Hello?
gamma integral formula.
Which integral formula?
In previous problem,
In previous problem, delta. Okay. Direct delta function, right?
no, then the previous. Second problem. Yes, wait.
Yes.
I think I faced one gamma s plus 1. You know the formula gamma s?
Gamma S is just I have written, right? Gamma S is your 0 to infinity e to the power minus z to the power s minus 1 dz.
Okay. I think I face some assignment problem. There
Okay.
is error. I think the same one, but they are given e power minus 2x, e power minus 2x. The option is not there. That's why I'm asking.
Okay. If you remember, then you can
I
write
think it's a
there.
plus minus is mismatched.
Okay. Yeah.
That's fine.
Some. Okay. Now, next problem, question 5. Hmm. Okay. Okay, this is very simple and it looks like simple. Okay. So when x lies between 0 to 7, it takes 1 and otherwise 0. Okay. Point 0 less than x less than 7 and otherwise. Okay. Fourier transform of this function 1 by root 2 pi. To the power alpha x dx and what? To the power alpha x divided by I alpha 0 to 7 and 1 by root 2 pi e to the power 7 I alpha minus 1 divided by I alpha. Okay. Yeah, this is very simple. So option D is okay. So yeah, see the next problem. So how to solve it? I mean, like, okay, let me first write the integration and then I will ask you. Okay, so fx is here x into e to the power minus. This is interesting actually. Okay, so okay. One thing. I forgot to mention. This is not only Fourier transform. This is Fourier cosine transform. Okay. The formula is instead of e to the power I alpha x, so you have just to you have to put just cos alpha x. Cosine for sine Fourier transform, it is sine alpha x, and for cosine transform, it is cos alpha x. So basically, what e to the power, if you see, no, 1 by root 2 pi minus infinity to infinity. Okay, fx e to the power I alpha x. So this is what? This is cos alpha x plus I sin alpha x. And cosine formula is cosine. So here you can write C. Okay, huh? And f of x. So yeah, instead of 1 by root 2 pi, this is basically 1 by root 2 pi 2 by 2 by root 2 pi. Okay, 2 by root 2 pi. And this is nothing but you can write root under 2 by pi. And the limit is 0 to infinity, and fx cos alpha x dx. Okay, and just put 2 by pi 0 to infinity. Function is your x time e to the power minus 2x cos alpha x dx. So do you have any idea how to integrate this?
Applying Laplace.
Yeah, right. So I wanted to know this only. Okay, so root 2 pi, you see here the Laplace, so by definition you will get the Laplace transform formula. Okay, so this is x cos alpha x dx. Okay, and this is nothing but Laplace transform of x cos alpha x, but at s equals to 2. Okay, at s equals to 2. So instead of s, so in the Laplace transform formula, so it is generally it is s, but here particularly as at s equals to 2 you have to calculate. Okay, so it is easy. Now to handle this type of Laplace transform x time fx. Okay, so you know the formula, derivative formula. Okay, already we have done, and this is nothing but dds of Laplace transform of dds of Laplace transform of cos alpha x. Cos alpha x. What is the Laplace transform of cos alpha x? So let me write first here cos alpha x, and okay, sorry, yeah, and s equals to 2 root 2 pi minus dds. Laplace transform of cos alpha x is s divided by s square plus alpha square. Okay, s equals to 2 root 2 pi. Yeah, you have to derivative this. Okay, um, minus s square plus alpha square whole square, and s square plus alpha square, and minus 2s square is equals to 2 root 2 pi. So this is nothing but s square minus alpha square divided by s square plus alpha square divided whole square, s equals to 2. Now you can put s equals to 2 root 2 by pi 4 minus alpha square 4 plus alpha square whole square. I hope it is clear, right? And it is okay. Root 2 pi. Yeah, so option A, right? Option A. Yeah, this is the only trick actually. Okay, so when so exponential like will come in integrand, so then you can think about Laplace transform. Okay, for this it is here the Laplace transform is not applicable. Okay, so when x lies between 0 to pi by 2, fx is sine 2x, otherwise 0. Fx sine 2x 0 less than x less than pi by 2, and 0 x greater than pi by 2. Here also they are asking for sine transform, sine Fourier sine transform. So I already told you sine fx this is root 2 pi, root under 2 by pi, 0 to infinity, fx sine alpha x. Okay. Root under 2 by pi, okay, 0 to pi by 2 instead of 0 to infinity. Actually, so fx is like non-zero when x lies between 0 to pi by 2, and then sine 2x sine alpha x dx. So you know the formula sine A sine B, right? 2 sine A sine B. So now this is 1 by root 2 pi, and 0 to pi by 2. This is 2 sine A sine B means cos cos A minus B.
Minus
Yeah,
cos A.
yeah. Yeah, cos alpha minus 2x minus cos alpha plus 2x, right? Now we can integrate them easily. 1 by root 2 pi sine cos alpha minus 2 sine alpha minus 2 x divided by alpha minus 2 minus sine alpha plus 2 and x is also there, 0 to pi by 2, and just you put the upper limit and lower limit. So yeah, sine alpha pi by 2 minus pi by alpha minus 2 minus sine 0 is 0 and sine 0, so only alpha pi by 2 plus alpha pi and alpha plus 2, and you know 1 by root 2 pi sine x plus x minus pi is minus sine pi, right? So minus sine alpha pi by 2 alpha minus 2, and here sine also sine x plus pi is minus sine x. This is also minus no sine x plus pi. So this is yeah, sine x cos pi, so this is minus, so minus plus, yeah, okay. Sine alpha pi by 2 divided by alpha plus 2, okay. Now I can take common 1 by root 2 pi sine alpha pi by 2 into 1 by alpha plus 2 minus 1 by alpha minus 2, and this is also 1 by root 2 pi sine alpha 5 by 2, so alpha square minus 4, alpha minus 2 minus root 4 is there, minus 4, and minus 4 by root 2 pi and sine alpha pi by 2 divided by alpha square minus 4, and you can write like this root 2, and if you put here root 2, so 2 root 2 by root pi also minus sine alpha pi by 2 alpha square minus 4, okay. Which option? That was second, sine minus 2 root 2 by root pi and sine alpha by 2 divided by alpha square minus 4. Yeah, always you have to think alpha should be not equals to plus minus root, otherwise it is not, like, it doesn't make sense. Okay, so option B is correct. Yeah. Okay, did you get it? Okay. Next problem. The Fourier transform of fx. Simple. You just have to calculate. Fourier sine. Okay, sine. So fx is given x 0 less than x and 2 and sorry 4 minus x 2 less than x less than 4 and 0 x greater than 4. Okay, so Fourier sine transform root 2 by pi 0 to infinity fx sine alpha x dx root 2 by pi integration 0 to infinity x sine alpha x dx plus 2 to 0 to 2 and 2 to 4 4 minus x sine alpha x dx. Okay, root 2 by pi. Okay, so x sine alpha x is there. So x cos alpha x by alpha and derivative of integration of sine is minus cos. And yeah, this is 0 to 2 and you can write okay, and so yeah, cos first of all the derivative of x is 1 and first sine alpha, the integration of sine alpha x cos alpha x by alpha, and then so the integration of cos alpha x is sine alpha x divided by alpha square, and this is 0 to 2 and then x minus 4 times x minus 4 minus x times sine alpha x, right? So 4 minus x into cos alpha x by alpha, and this is minus, and similarly but minus should be there because of 4 minus x. The derivative of 4 minus x is minus 1, and this is sine alpha x by alpha square. Okay, 2 to 4 root 2 by pi, and yeah, if you put upper limit, so you will have minus 2 cos 2 alpha by alpha and plus sine 2 alpha by alpha square, and for lower limit so this both are 0. Okay, and for upper limit for the second term 4 minus 4 is 0 and minus only minus sine 4 alpha by alpha square, when 4 minus 2 2 and minus plus, so 2 divided by alpha cos 2 alpha and minus plus sine 2 alpha divided by alpha square. Okay, so this is 2 times sine 2 alpha by alpha square, and 2 by alpha, this is cancelled, these are cancelled. Okay, and 2 okay, so finally this and this, yeah, root 2 by root 2 sine, okay, let me check. Sine 2 alpha, 2 times sine 2 alpha by alpha square, 2 times sine 2 alpha by alpha square, and minus sine 4 alpha by alpha square. So that is the final answer. It will be alpha square 2 sine 2 alpha minus sine 4 alpha. Okay. Yeah, root 2 pi 2 sine, so sine 2 alpha is there. That's why option C, only option C. Okay, sine 2 alpha, 2 sine 2 alpha minus sine 4 alpha divided by alpha square. Okay. Okay, so yeah, next problem. Fourier cosine transform. So your fx is what? X when 0 less than x less than pi and 0 x greater than pi. So Fourier cosine transform root under 2 by pi integration 0 to infinity fx cos alpha x dx. This is very easy. Sorry, 0 to infinity. So instead of 0 to infinity, 0 to pi and x cos alpha x dx. Root under 2 by pi. Just integrate minus, sorry, cos is sine alpha x divided by alpha, and what is the integration? Cos sine cos. So minus sine alpha x by alpha square. Sorry, cos alpha x by alpha square, and on the 0 to pi. And yeah, sine root 2 by pi. So alpha may not be integer. Okay, alpha is any real number. So that's why your x sine alpha pi divided by alpha, or sorry, this is also pi. Pi times sine alpha pi by alpha, and 0 is for lower limit it is 0, and minus cos alpha pi by alpha square, and plus 1 by alpha square. Okay, so after simplification to root under 2 to pi, alpha square is common in denominator, alpha pi sine alpha pi plus cos alpha pi minus 1. Okay. Okay. Yeah. So sine alpha, no, alpha pi sine alpha. So that's the option B is correct. Okay. Is it okay?
Yes, sir.
Okay. Hmm. No problem. 10 is yeah. In the Fourier sine transform of fx e to the power minus x. Here also I already told you. Okay. So already hint is there, but so e to the power minus x is there. So that's why Laplace transform is applicable. Okay. And also this hint is there, and Laplace transform of sin alpha x by x is tan inverse alpha by x. So we'll use this. Okay. So basically fx is e to the power minus x by x One thing, yeah. So since x greater than 0, so it is okay, well defined, no problem. So this interval of fx root 2 by pi 0 to infinity fx sin alpha x dx root 2 by pi 0 to infinity e to the power minus x by x sin alpha x dx. So it is simple, right? So if you see 2 by pi, this is Laplace transform of sin alpha x divided by x is equals to 1. Okay, similar problem like previous one. Okay, so already it is given what is the Laplace transform of sin alpha x. I don't know what is happening. A minute. Okay, so it is given, right? Laplace transform sin alpha x by x is tan inverse alpha by s. So root under 2 by 5 tan inverse alpha by s and s equals to 1. Finally, you will get tan inverse alpha. Okay, so this is the final answer. Okay, root under 2 by 5 times tan inverse alpha. So option D. Yeah. Okay. Now this is like another problem. Okay. So here using Fourier transform, Fourier sine transform basically, why Fourier sine transform you have to use? See, so integration is 0 to infinity, and after that sine alpha is also there. So since integration is 0 to infinity, you cannot use Fourier transform only. So you have to use either Fourier sine or Fourier cosine. So here, so because the sine alpha is in numerator, so you can use Fourier sine transform. Okay, but main thing is like here hint is there, but if you don't have any hint, then how you will like choose this function? So this is the main thing, because see here integration 0 to infinity alpha sine alpha is there and e to the power alpha square by 2 d alpha. So basically integration 0 to infinity uh, x x what x and e to the power minus x square by 2 and sine x dx. Okay, so this is the like Fourier transform, Fourier sine transform at point like when alpha equals to 1. Okay, so by using Fourier sine transform you can evaluate this type of integral. Okay, okay, so let me check. Oh, what? Oh, I don't have space. Okay, I forgot to keep. Okay, so one thing I can do. Okay, I am writing here only. No, no problem. Okay, so here basically you have to consider this function. Okay, fx is ax e to the power minus x square by 2. Okay, then Fourier sine transform of fx root under 2 by pi integration 0 to infinity x e to the power minus x square by 2 sin alpha x dx. Okay. And one thing, I am not going to evaluate this integral. Okay, already if you check in lecture, you can see this is nothing but alpha time e to the power minus alpha square by 2. Okay, so you can check it. Okay, so this to evaluate this integral, uh, you need like some different approach. Okay, okay, no problem. So this is this thing already you can find in lecture. Okay, okay. So I'm not going to solve this integral. And now, so Fourier sine, this is like given. So Fourier, so Fourier sine transform of fx is this. So fx is your e to the power x square by 2. This is Fourier sine inverse alpha e to the power minus alpha square by 2. So now we have to use the inverse transform to infinity alpha e to the power minus alpha square by 2 sin alpha x d alpha. Okay, okay, and root 2 pi. Now what? Now is alpha sin alpha x divided by e to the power alpha square by 2 d alpha. And now you do one thing, you just put x equals to 1 in both sides. Okay, then you will have the value of this integral. Okay, just put x equals to 1 on both sides. Then so root 2 by pi integration this 0 to infinity alpha sin alpha divided by e to the power alpha square by 2 d alpha. And in right hand side if you put so 1 into e to the power minus half. So basically this is the value of, I am writing here root pi by 2 times e to the power minus half. So e to the power minus half means you can write this. Okay, so option B is correct. Okay, this is quite similar problem. Okay, but here Laplace transform is not given, so but you have to use Laplace transform. Okay. Oh, fx is your x time e to the power minus x, and Fourier sine transform fx root 2 by pi integration 0 to infinity x e to the power minus sorry, it is x sine alpha x dx root 2 by pi 0 to infinity e to the power minus x sine alpha x dx. Okay, so this is Laplace transform of x sine alpha x at s equals to a. Okay, and you know what is the Laplace transform x time fx? This is minus derivative of Laplace transform of fx. Okay, and ft. So yeah, I want to say, you know the Laplace transform of TFT. This is minus DDS Laplace transform of FT. The well-known formula. Already we have seen many times. Okay. So root 2 by pi minus TDS of Laplace transform of sin alpha x is equals to a. Okay, root 2 pi minus DDS alpha divided by s square plus alpha square is equals to a. Root 2 pi of what? This is s square plus alpha square and minus is also there. So minus alpha, so that's why this is only alpha and 2s. Okay, 2 alpha s. Okay, and is equals to a. Now we just put s equals to a. So root 2 pi 2 alpha a divided by a square plus alpha square whole square. This is the final answer. Okay. Yeah. Option C you can check. Root 2 by pi, root under 2 by pi, 2 alpha square plus a square whole square. Okay. So this is the problem 13. Fourier cosine transform of fx equals to sine 2x when x lies between 0 to pi and x greater than pi at x 0. Okay. So fx is your sine 2x when 0 less than x less than pi, 0 x greater than pi. So Fourier cosine transform of fx is root 2 under pi 0 to infinity fx cos alpha x dx root 2 by pi 0 to pi sine 2x cos alpha x dx. So similar formula. So you have to do it 1 by root 2 pi. So here I am multiplying 2 and 2 in numerator and denominator. So yeah. Okay. So this is 2 sin a cos b. So sin integration 0 to pi sin a cos b. So sin a plus b 2 plus alpha x plus sin a minus b. So you can write minus sin b minus a sin alpha minus 2 x dx. Now you can integrate easily. Okay. So the integration of sin is minus cos alpha plus 2x divided by alpha plus 2 plus minus was already there. So that's why plus cos alpha minus 2x divided by alpha minus 2 and 0 to pi 1 by root 2 pi okay, put minus cos alpha plus 2 pi by alpha plus 2 plus 1 by alpha plus 2 and pi plus cos alpha minus 2 pi divided by alpha minus 2 minus 1 by alpha minus 2. Okay, 1 by root 2 pi cos cos pi alpha times plus 2 alpha. So of course you know 2 alpha is period. So basically this is cos alpha pi and alpha plus 2 and plus also cos alpha pi alpha minus 2 plus alpha square minus 4. One thing, we can do it at the same time. Alpha minus 2 and okay, so 1 by root 2 pi. Now cos alpha pi common 1 by alpha minus 2 minus 1 by alpha plus 2. And here 1 by alpha plus 2 minus 1 by alpha minus 2. So you can easily simplify it. This is alpha plus 2 minus alpha minus 2. This is 4. So 4 divided by alpha square minus 4 into cos alpha pi. And this is minus 4 because alpha minus 2 is there at first and then alpha plus 2. So minus 4. Minus 4 by alpha square minus 4. Okay. Yes, this is the final answer. 1 by root 2 pi, 4 by alpha square minus 4. Yeah, you can, I don't know, an option. Yeah, so you have to simplify more. So 4 by root 2, so root 2 and root 2, so what? 2 root 2. 2 root 2 by root pi, and also 1 by alpha square minus 4, and cos alpha pi minus 1. And when alpha square not equals to 4, that is alpha not equals to plus minus 2. Okay. Yeah. So option A is correct actually. Yeah, option A is correct. So like they just kept 4 by root 2 pi instead of 2 root 2 by root pi. Okay. Okay. I hope it is clear. Now this is the last problem. Okay. Very simple. Any question?
In previous problem, alpha lies between alpha is real number or integers.
Real number, of course, real number, not integers. Then you can if it is like integers, then you can simplify this. It is always real number, any real number.
Okay, sir.
Yeah, yeah. Maybe positive, maybe negative. Okay. Yeah. So you can you can see the lectures. Okay. There are many things. Okay. At least you can read all the PDF. Okay.
Sir.
Yeah. So fx is like root under 5 by 5 relation x less than 5 and 0 x greater than 5. So Fourier cosine we have to find. So root 2 by pi 0 to infinity fx cos alpha x dx. Root 2 by pi 0 to 5, right? 0 to 5 root pi by 5 cos alpha. Very simple. Root pi by 5 is your constant. So you have to integrate. So root 2 by pi into root pi by 5 into so cos alpha, the integration of cos alpha x is sin alpha x by alpha 0 to 5, and here root pi cancelled and root 2 by 5 only, and sin only 5 alpha by 5, sorry, by alpha, and sin 0 is 0. So root 2 by 5 sin 5 alpha divided by alpha. And which option is correct? Root 2 by 5 sin 5 alpha by alpha. Yeah, option A. Yeah, this was the last problem. So I hope you got it right. Hello. Yeah, you got it right.
So,
Yeah. So, do you have any like another problem, like you want to ask?
no, sir.
Okay, thank you. So then we will meet on the uh, next Tuesday. Okay, at the same time at 7 p.m. Okay. Okay.